students, we are in part 4, the last part of module 5, combinational logic circuit. We're now going to look at how do we design an actual combinational circuit to produce a function. What's important is we have to look at the problem statements. And from that problem statements, we're going to go through a few steps. And towards the end, we're going to produce a Boolean expression so that from there we can build our circuit. So here it is. You see there are 6 steps in designing a combinational circuit. The keyword here is combinational. Yeah? You will hear the word sequential from module 7 and 8. Yeah, you will hear the word sequential circuit, different from combinational circuit. Here in module 5, we are talking about combining all the gates to produce a function. So please read how we are going to design a circuit. So obviously, the first thing we need to do is to understand the problem, right? Everywhere in the world, a lot of problems. So we must understand. What are we trying to understand? What is the input? Okay? What creates the problem, or what are we trying to solve? So what is the input? And then what is the output? What is it that we want actually? And what is the relationship between the input and the output? So doing that, yeah, so in step 2, we are going to convert our problem statement to a Boolean expression or truth table. Yeah, most probably it's easier for us to go to a truth table. Having a truth table, then just like in module 4, we're going to simplify using K-map. Let's do K-map, yeah, instead of Boolean algebra or other technique. You know how to do K-map? Let's use K-map. We get the simplified equation from the K-map, draw the circuit using our basic gate, and then most probably let's extend it. Let's just use our universal gate, whether NAND or NOR. And then finally, you can use dual symbol also. So 1 to 4, yeah, 5 and 6 is optional. 1 to 4 is the steps to design a combinational circuit. As explained in the previous slide, it is very critical, step 1. If you wrongly understand this problem, meaning you got your input wrong, yeah, the number of input wrong, you got the relationship wrong, yeah, of course you must also have the output. If this is wrong, yeah, whatever step, of course you're going to produce the wrong circuit. So very, very important to understand problem statement. Finding the problem is the most difficult part in anything that you do, in research, in life, yeah. Finding the problem and trying to solve it. Once you find the problem, it's kind of very easy to solve because you have the step. But you must make sure that you got the correct, you translate, yeah, correctly the problem into truth table. So understand, please. So let's look at our first example. So it's kind of like, okay, are you testing my digital logic knowledge, or are you testing me English? Both. But don't worry, yeah, in the exam, if you don't understand anything, any word, or you can ask the lecturers, you can ask me. Okay, let's read this together. In a certain chemical processing plant, a liquid chemical is used in a manufacturing process. The chemical is stored in 3 different tanks. A level sensor in each tank produces a high voltage when the level of chemical in the tank drops below a specified point? How is it? So try to imagine this. Okay, maybe, you can draw this. So the question asks, design a circuit that monitors the chemical level in each tank and indicates when the level in any two of the tanks drop below the specified point. Okay, so the first thing, always, what is the input, what is the output, and what is the relationship? First, what is the input? So maybe drawing would help. So there are 3 tanks. Okay, a huge chemical processing tank. So maybe we name it A, tank B, and tank C. So there are 3 different tanks. And in the tank, there is a sensor. Yeah, there is a sensor. So this blue dot is a sensor. Okay, and so the sensor will produce a high voltage when the level, so inside this tank there are chemical, and if the chemical drops below a specified point, so let's see the point is halfway. Yeah, halfway. If the chemical drops below, so in this area, if the chemical is in this area, you will produce high. Okay, and if your chemical is above that middle area, you will produce low. So that is our input. Tank A, tank B, tank C. And then, this is our input. Our output will be circuit that monitor the chemical level. So whatever sensor will be sent to a monitor here. Okay, so it will be sent to a monitor. So this will be our output. Maybe we call it monitor X. So it says if 3 of the chemical level is above, meaning okay. Yeah, we have enough chemical. So no alarm will be issued. But let's say tank A goes below, only 1. No problem also. It will, the alarm will go off only if 2 of the tank, let's say either A and B, below the level, or A and C, or B and C below, or all 3, of course. If all 3 below the sensor, the alarm will sound. So that is, so try to imagine this. This is our input, so we have our output. And the relationship is, this is the relationship. Indicates when the level, this one. This is the relationship. Still in the first step, once you have identified A, B, C as your input, you need to, so of course in the input, each input you will have either 0 or 1, right? B also either 0 or 1, and C also either 0 or 1. So all 3, A, B, C is the same, Sensor sense the chemical level. So you figure it out, you decide. If 0, what is it? 1, what is it? So here, the slide choose, if drop below, it will be high. So 1 will be below, 0 means above the level. You must decide. Same with output. So our output X, what is 0? What is 1? In this case, 1 if active means 1 alarm. Yeah, when 2 or more tank is below, 0 off alarm. Yeah, so every input and output you must decide what is the true, what is the false meaning. So second step, you have you know how many input, you know how many output, you name the input and output A, B, C, D, A, B, C, X. What is 0 and what is 1? You draw the truth table. Yeah. So once you know the A, B, C, so please ignore X, ignore output first, the input. Yeah. Please write down the input first, fill up the input. And make sure you fill up correctly from 0. I've seen in your labs a few of you, yeah, start with 1, 1, 1. Yeah, and some not even following biggest to smallest, yeah, but just random. Please do the pattern 0, 1, 0, 1, 0, 1. Start from LSB, then double 0, double 1, then 4, 0, 4, 1. All right. So once you have this, the first one means 0. Do you remember what is ABC? Yeah, 0 means above or 0 means above. Yeah, no problem. But 1 means low. So 0, 0, 0 means above level, above level, above level. There is why there is no alarm, 0. Yeah, alarm, 0, no alarm, 1 is alarm. So when it is only alarm? When 2. Yeah, 0, 0, 1, 0 also, because only 1. So you need here 2. So tank B and tank C low, below, then you get your alarm. And then what this one? A and B also alarm. Sorry, A and C just now. Now A and B, alarm. And of course, all below, you also get alarm. So the rest is no alarm because either only one tank is below or none of the tank is below. So that is your truth table. Remember, fill up your input first. Then looking at the relationship, you fill up your output. Once you have that, the third step is key map. So which one? Active high or active low? You have 4, 0 and 4, 1. So when you have the same number, let's go for active high. So we're gonna do SOP, circle our ones, and we get our simplified equation. Okay, what's next? So this is step 3, and then step 4, we draw. Okay, so we draw AB. Yeah, so from tank A, the sensor, to tank B. And then this is tank A and C. This is tank B and C. Plus, plus, you have an OR. So this is an OR invert. So when we have an OR invert, very easy for us to, if we have to do step 5, using what? Let's do NAND, yeah? And or invert logic automatically. You don't actually have to do conversion or bubble, yeah, dual symbol, whatnot. But of course, in the exam, yeah, if we ask you to prove it, you have to show how it's done. But let me tell you, yeah, we know this, that this will produce 4 NAND gate. So implement the circuit using universal gate. So convert this to how many gates? Either you convert, yeah, but this is very easy. I'm not going to use the conversion. I'm going to use the bubble technique. Introduce 2 bubbles on each wire. Then this is already NAND. This is dual symbol, negative OR, converted to, which is actually NAND. Yeah? Okay, that's my answer. But this slides is first using the, what is this? Conversion. So 1 N is 2 NAND, 2 NAND, 2 NAND. And OR is the cousin of NAND, meaning going to know how many? 3 NAND. Where is our 3? And then which one we can cancel? Which one we can cancel? This, okay. This and this, one cancel. This and this, one cancel. This and this, one cancel. So I end up with 4 NAND gate, same thing. Yeah? So if you trace the equation, you will get this. And then if you De Morgan, yeah, you will get this, which is, yeah, this is basic gate. This is NAND. The first one is NAND equation, using NAND. So from NAND, you use De Morgan, you get your basic equation for basic gates. For NOR gates, we can't use bubble, but how many NOR here? 3 NOR, 3 NOR, 3 NOR, 3 NOR. This is 2 NOR. So 3, 3, 9, 11. Quite a lot. Anything that we can cancel? No. I don't see anything that we can cancel. Right? So we have actually, how many? 9, 11. Yeah? So in this case, NOR is not a good gate to use for this circuit. NAND is better. We only need 4 NAND gates. So in this question, actually, yeah, part A is asking you to do the conversion, yeah, the conversion of the universal gate from the table 1, 2, yeah, and for question B, we use the dual symbol. In dual symbol, we use the bubble just like the one I showed you previously, because yeah, in this case bubble is much faster and much easier. But for NOR gate, yeah, the bubble, so for NOR gate, yeah, we use our odd, even, yeah, a third technique. So we have a few techniques. So I've shown you first conversion, yeah, convert the universal gate to the equivalent, and then the second one is you use the what is it? You use the dual symbol by introducing the bubble. Okay, and the third one, in this case, we use our odd, even, where we change the odd level to the dual symbol to produce our basic gate. How are you guys holding up? Masih okay? Tak okay? Sabar na? Okay, let's continue. Okay. So the previous example, I've shown you, yeah, one output. sometimes there is situation where the same input, but you need to produce two output. So maybe you need to sound an alarm, and also you also need to close the door, open or close. Yeah. So same input. Yeah. Same input condition ABC, but this ABC will trigger alarm if what AB is what. It will also close the door if BC is what. So same input, but you need to produce multiple output. So look at this example. Design a combinational circuit with three inputs. So this is easy. Okay. The previous statement, the previous problem, we give you problem statement, you have to decide. We didn't even give you the keyword input, but in this case, we gave you the keyword. Where's the keyword? Here, yeah, input. So you don't have to think, what is the input? We give you three input, A, B, C. So easy for your truth table. And also we tell you two output, X, Y. Meaning X depends on A, B, C. Y also depends on A, B, C. So before you do anything, you need to fill up the truth table first. 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. So I have my input. So my output, there are two output. One is X, and the other one is Y. Two different output. Okay? So we have our input already. Now we figure out what to put in our output X and also output Y. So look at the relationship. When the binary input is, so this is in decimal, yeah, it's either 0, 1, or 2. So let's label this 0, 1, 2, 3, 4, 5, 6, 7. So if it is 0, 1, or 2, the binary output is 1 greater than the input. So the output will be 1 greater than input. So if the input is 0, the output will become 1. If the input is 1, the output will become 0. If the input is 2, the output will become 3. There you go. What's the other one? When the binary input is 3, 4, 5, and 6, the binary output will be 3 less the input. Meaning 3 minus 3, 0, 0. Yeah? 3 less. So 4 minus 3, 0, 1. 5 minus 3, 2. 6 minus 3, 3. Okay, so you have the first relation. The second relation, this is, look at this. The binary input will never be 7. What is that? Correct. That is don't care. Doesn't exist. Never. So now you have your truth table. Questions? So if you have questions, put it inside the forum in e-learning. So this is the step. You can have a read how it's done. I've showed you in the previous slide already. So same one. Now what do? We have the truth table because we have two output now. So we are going to have two K-map. One is X, the other is Y. So one K-map for X, one K-map for Y. And the input is A, B, C. Here A, B, C. So you have X. So you have X equals to BC bar plus B bar C. Y equals to C bar. Then you draw. Yeah? You draw first for circuit X. Then you draw for circuit Y. Of course, because both circuit X and Y comes from the same input, please combine them. Alright, so you have two output here, X and Y coming from the same input. So, look, yeah. So this circuit doesn't need A actually, meaning whatever A is doesn't matter. It all depends on B and C. Yeah, your problem statement just now. Interesting, isn't it? So I want you to continue this. Please implement the circuit using universal Gibbs and then draw the final circuit using dual symbol. So please test your knowledge of NAND and NOR and also bubble, conversion, etc. Another example, you need to try this. So design a logic circuit for a car alarm that fulfill the following requirement. So in this one, yeah, you don't actually need, so this is another way we can show you. You don't actually need to draw the truth table. You can produce a Boolean expression directly from the problem statement. Because look, let's read this together. The alarm will go off if the alarm system is activated and any of the two doors in the trunk are open, or if the vibration sensor is activated and the key is not in the ignition. Okay, hold on. The output is the alarm. This is the output. The output is the alarm. Okay. So you can do X or Y. It has 0 or 1. So the alarm will go off. Yeah? So either the alarm will either go off or on. If so, how does the alarm go off? What is the input you need? So now this is all the input. Red is all the input. So if the alarm system activated, so alarm system is input 1. And then doors in the trunk open, yeah? Or vibration sensor is activated and the key is not. So 4 input, alarm, doors in the trunk, 2 doors in the trunk, vibration sensor, and the key. Okay, you have your input. What is the relationship? So you have your output alarm, you have the 4 input. What's the third one we need to know? The relationship. So the relationship is here. If the alarm system is activated and, so and is dot, yeah, or X. Yeah, I'm gonna do dot lah. Dot, big dot N. Or, what is or? Or is plus or gate. And here, because we have 4 inputs, so we have 3 connection. Dot plus dot. Okay, so our output, I'm going to name it X. So our output is alarm. It will go off. Okay, English. Go off means it will sound. Yeah, true, on. So it will sound, I'm gonna, easy English, I'm just gonna write for true. You have a sound, the alarm will have a sound. 0, silent, no alarm. Alright. And then I'm gonna, let's look at the table input here. I'm gonna change a few input expression. I'm gonna say alarm system. So alarm system, either the condition high activated or false not activated. And another thing, this vibration, I'm gonna use a sensor. So the sensor will be true, will be vibrate, true, not vibrate, false. Alright. So for the input, we have 1, 2, 3, 4, 5, 6 input. So let's do the K-map. Can you? I can't, because I only teach you how to do 4 input K-map. Yeah, I think at most you can do is 5 input. So this is an example where this is an example where we can skip K-map and go straight from problem statement to Boolean expression, because you can't do 6 input K-map. So how are we going to do it? We're going to look at all this keyword, yeah, and or not. All right. So I'm going to try this. Let's do this. So we have all our variables. So X is our input. X will sound, yeah, will go off. X will sound if equals alarm system is activated. A is true, activated. And is dot, or we can change to bracket later on. Any of the 2 doors. So the 2 doors is, in the car we have driver door, we also have passenger door. So any of means either driver or passenger. You actually have driver or passenger. So you need to also understand what any of means in English. So either driver door is open, or passenger door is open, or the trunk door is open. I'm going to put a bracket here. Alright, so that is our one term, because why? We have a comma dash. I'm going to assume, yeah, we finish our first term. So our alarm will go off, yeah, will sound if you activated the alarm system. So you can imagine it like this. Your house has an alarm system, but if you don't put in the postcode 0598, yeah, if intruder comes in, even though you have an alarm system, but if you don't activate it, no sound will come out from your alarm. Your house will keep quiet. But if your alarm, you have an alarm and you activate it, yeah, you put in your passcode 0598, intruder comes in, alarm will go off, will sound. So that is what it means, right? So if driver door is open, passenger door is open, trunk door is open, but you don't activate the alarm, so it is false, nothing will happen. As long as driver door is open, but passenger door closed, trunk closed, but driver door is open and your alarm is activated, your alarm will go off. So that is the first term. Then next we continue, or, so we're going to continue the next term. Or means plus. The sensor is activated, so E, yeah, and here and the key, so key is F, but we have here not in ignition, means we have a prime here, F not. Okay, so that is another term. So we have 2 terms to activate our alarm. So there we have it. So I hope you can slowly rewind this video, look at it again, and see how I managed to convert this problem statement to a Boolean expression directly without K-map. But of course, you need to identify what is the alarm, what is the output, what is the input, and then what is the condition 0, 1. What is 0, what is 1? and then find all the keyword and or not to translate that into the gates. If you have question again, please ask in the forum in e-learning, or when we resume our class, our synchronous class, you can also ask me question. Discuss with your friends. So let's look how do we draw this? Yeah, look. So we can draw this. So this is output X. Yeah. So alarm system is, what is alarm system just now? E, driver door B, passenger door C, trunk is D, vibration is E, sensor, key ignition is F. So if we trace the Boolean expression from the left, this is B plus C. Yeah, and then this is D, meaning the output is B plus C plus D. And this is A, we have A dot B plus C plus D for this one. Yeah, alright. And then this one, this is F bar, this is E. So the output here is E dot F bar. So X equals to, this is R, A, B, C plus D plus E, F bar. Yeah, the same as in the previous slide. Confirms. Please, yeah, we have another example here. Read this and try, yeah, to get the answer. So there are one answer here for example 1 and this answer for example 2. Read it slowly and try to do on your own first, and then look, check your answer with the answer in this slide. So that's the end of module 5. Sadaqallahul Azim. So what do we learn? So the summary is, we learn about, here we have AND OR logic, or AND or invert logic. Okay, for SOAP and for POST. Okay, why? Okay, go look at part 1 video. And then you have the universal property of NAND and NOR, which can represent all our basic gate, and NOT, OR, and also the other NOR represent NAND, NAND represent NOR. And then we also have the dual symbol. Okay, this equals, this. Negative and the other one also. This equals, N becomes OR, bubble on the front becomes bubble after becomes bubble before. That's dual symbol. So you need to how to introduce the bubble, yeah, to simplify. And then lastly, part 4. We conclude with, using all of the information, the knowledge that we have, we try to create a functional circuit from a problem statement given to us. So the step is, from the problem statement, identify the input, identify the output, identify the relationship. Okay, and then draw the truth table. From the truth table, K-map. From the K-map, you can draw the circuit, either using basic, universal gate, or dual symbol. But there are also situations where you can have 2 outputs instead of 1. So 2 output from the same input. And the other third problem is where quite impossible for you to use K-map. So you can jump directly from problem statement to what? To circuit, Boolean expression and circuit. So once you know this, do extra work on the tutorial, because after this you are going to attempt lab 2. So congratulations, the end of module 5, combinational logic circuit. Bye.